Well, good morning, and thank you for joining us. My name is David Eagle. I'm the FME Division Manager at One Spatial, and in this session, part of our webinar series, we'll be talking about FME specifically for the transport sector. So very briefly, just a couple of minutes about who we are. We are One Spatial. We're headquartered in the UK in Cambridge, but we've got a number of offices globally, and we focus on a handful of key industry sectors, some of which we'll touch on in the session today. Those are around government, both local and central, utility companies, whether they're water, electricity, gas or telecommunications, and transportation sector, including all of the engineering organisations that support the different parts of our infrastructure. We work with a number of key customers and technology partners, and the focus of today's webinar is around the relationship that we have with an organisation called Safe Software, who are the makers of FME, and One Spatial are a platinum partner of Safe Software. So I just want to touch on some of the capabilities of One Spatial in respect to our relationship with Safe Software. We're a platinum partner, and that means that we do a lot of things around the technology stack from Safe. And we've been a partner since 1999. Initially as a development partner because we incorporated the FME product under the bonnet, under the hood of a lot of our own technology to extend its format reach. But we these days provide support and maintenance, and we look at the capabilities and uses of both FME Desktop and FME Server, and also FME Server in the cloud environment, so FME Cloud as a managed service provider. So we have a number of FME practitioners around the business. Many of those also have some of the certifications that Safe Software accredit our staff with. And these are accolades that individuals gain themselves to support particular areas of our business. So whether they're a certified FME professional, a certified FME trainer, or a certified server professional, we've got plenty of individuals who can help you out with your FME requirements. Some of the things that we do are listed here, but really if you'd like to find out more about anything to do with FME or the product capabilities, or you have training or consultancy requirements, please just drop us a note and some questions to fme@onespatial.com, and we'd be happy to get back to you with some assistance. But we help organisations work out whether FME is the right product for them and do evaluations. We look at different mentoring types of work with building FME workspaces on a one-to-one basis. We do private and public training at our office or yours, and all of our FME consultants that deal with those kinds of engagements have got more than 10 years experience with the FME product. So, focusing on today's agenda and FME for the transport sector, we wanted to touch on a couple of overarching themes that have cropped up on projects and work that we've done within the transport discipline. So I'm going to touch on those to begin with. And then there are an assortment of data processing challenges and availability challenges around data in both the public transport arena and also private transport methods. And I wanted to highlight a few of those examples of where we can get data from and how we can process it, what we can do with it, and there's going to be plenty of examples along the way. So it will be really a webinar to whet your appetite to some of the capabilities of FME in the context of some of the different data sources that are out there. So I hope it's of interest to you. So first of all, I'm going to focus on some of the overarching themes, and as far as I'm concerned over some of the work that we've been doing, they group together quite neatly into four main themes. So first of all, data format translation for proprietary packages. At One Spatial, we build software and we resell products built by a handful of other companies. But at our heart, we're a collection of consultants, and we help organisations manage their data. So we do see quite a lot of transport-related data, whether it's on projects with local authorities, engineering companies, or network operators. So a number of transport standards seem to exist out there. So the Department for Transport maintains something called TransExchange, which is a standard in the UK. It's a nationwide standard for exchanging things like bus schedules and related data. It's a standard that was devised over 18 years ago, and it's built on XML. A lot of formats or standards are built on existing formats that we use for other things. So if you want to find out more, then go and have a look at gov.uk and search for TransExchange. And there's a bit of more detail about the TransExchange format in one of the demonstrations later on, so you'll be able to get the spelling for the format at that point. ATCO CIF data was the precursor to TransExchange before it was modernised, but there's still a lot of that old data about. I found actually just a number of organisations publishing ATCO CIF via data.gov.uk just this week, so that's some sort of highlights that not all formats go away very quickly. Even older standards, you often have a need to process them, whether it's historic data or data that has been exported from an older system. When it comes to importing and exporting content, there are a lot of proprietary transport planning packages available. If you're interested, for example, in advanced traffic simulation software, there's a technology called PTV Visim that might be of interest. Go and have a look at ptvgroup.com. And then there's tools like Arcady and Picardy. Arcady looks at enabling assessment of roundabout capacity and delays, and Picardy is much more focused on priority intersections. And those tools are just a couple of tools that deal with vehicle analysis on the road network. I've not even touched on multimodal interchanges or rail network capacity analytics. One of the things that dedicated packages like this have in common is a need to consume network and traffic data in a specific format. Often products like this need data preparing in a specific way, and they can only ingest the data in specific formats like DXF, it's an Autodesk format, Excel, Microsoft MIFMID from MapInfo, and Esri Shape format is also a common interchange format. The CAD to GIS challenge, I mean, this sector produces a lot of data from both CAD and GIS systems. Both have got areas in which they excel, and that's why they exist. Commonly, this data has to be exchanged between multidisciplinary teams, and as the two types of data are very different, issues such as projection, attribution support, geographic tiling, precision, labeling, and more, all of those have to be handled. Then there's the need for a base map. Displaying any transport-related data or resulting analysis generally involves some sort of base map, whether you're planning the implications of a new rail route on existing land parcels or dwellings, or you're measuring carriageway width to identify the potential for shared use with cycles or pedestrians. You're going to need a base map of some sort. In the UK, we've got very rich data available from a couple of providers. OpenStreetMap is a rich source of open map data, and of course we've also got access to the Ordnance Survey, who produce some of the most detailed and feature-rich cartographic data in the world. So we'll touch on that in a little bit of detail shortly. And then web-based data is a really interesting area to touch on. We live in a time, I think, when many of us would find it pretty hard to understand how we manage in our private lives without web access or use of the internet. And professionally, many of our daily used tools are moving into the cloud or moved a long time ago. So whether that's our email or our documents, we're having to adapt to new ways of working. The transport sector is one where a lot of our data sources are coming from hosted services or APIs, all at the end of a URL. So you won't be surprised really for that reason that we're picking up on these themes, because in all cases FME has got your back really, and it can help you handle each of the challenges. So what we're going to do for the rest of the session is have a look at some of the specifics of these. Looking here at the public transport rail arena, CAD to GIS scenarios are really common, especially around major infrastructure projects. And the reason for that is there's often a parent organisation or a governing body involved in managing the project. And then there are perhaps lots of contractual organisations or engineering firms that are perhaps in some cases grouped together in joint ventures. And those individual organisations need to exchange data. And managing that flow of the master data between the parent organisation and the contractors is vital. In particular, FME has got a really strong role in transforming the structure of the data, the schema, and also the format, because no two organisations work with the same system in a lot of these projects. So the key thing is that FME can be used to help checking data out as a package, providing it to an organisation who can edit it and then check it back in, but through a controlled workflow. And one of the reasons for touching on this is a project that we're involved in at the moment allows us to take our own technology, the One Spatial management suite, and couple it with two of the products that we work with and favour. GeoCortex on the web mapping side of things, and FME from an ETL perspective. In this scenario, for this customer, what we're doing is putting together a suite of tools that allows us to have a managed checkout and packaging up of data, and then a return journey. In this case, the users access a web map and define the extents of the data that needs to be checked out. Our One Spatial management suite manages the job request, and in this case requests that FME server runs a workspace that was built with FME desktop, and it pulls data out of Oracle, which is the GIS environment, and writes it in this case to MicroStation DGN. And importantly, it maps the data to the new schema, and makes sure that no content is lost. The return journey is when the data is checked back in, and the important thing is that FME does a sort of a high level element of change detection against the data that was originally checked out to see what's different now, and that then determines what kind of validation routines that we run using our One Validate technology on the process, on the data, to make sure that we can identify what's changed and how the master data environment should be updated. When it comes to working with specific engineering projects and large-scale infrastructure, we often see a requirement to work within different projections. You're probably aware that some project areas often have their own custom projection. So the way that the data is projected onto the Earth's surface differs in different parts of the world. And certainly in the UK, we see a requirement to take data between latitude and longitude coordinates to British National Grid and back again. But often for projects, you might be aware that Heathrow Airport, for example, has got its own projection system. The East Coast Main Line route has its own projection. There are different requirements around precision that are necessary for certain projects. Something that is cropping up a lot at the moment, and it's as a result of projects like High Speed 2 or HS2, is the use of a projection called SnakeGrid. There is a SnakeGrid projector transformer that is available that you can use inside FME, and that allows you to take project data from British National Grid and latitude and longitude and move it to SnakeGrid and bring it back again in the other direction. So if you go and have a look at the SnakeGrid website, you'll see that, for example, you've got access to the SnakeGrid projector tool for FME. There's a bit of description about what it does, and it's a technology and capability born out of the University College of London. What we have access to is now a specific transformer. It is an extra cost transformer, and we're more than welcome to provide you with a little bit more detail about that tool. But as you can see, you can specify the source and target coordinate systems, and it works off particular parameters. So let's go and have a look at what I mean here. So I'm going to launch FME Workbench. So this is the application that we use to construct our ETL, our extract, transform and load processes. And you can see here that we've got an AutoCAD data set reading in, and I'm actually writing it back out to AutoCAD. But I've just blocked off this pipeline at the moment. I've got some transformers on the canvas. I'm defining the coordinate system as SnakeGrid, and those of you who know FME already know that SnakeGrid isn't defined in FME as standard. So when you get the SnakeGrid transformer, then you get instructions on how to define that custom coordinate system in FME. And if I just run this now just to the inspector, I'm going to take the data and just push it to, so this is a SnakeGrid defined projection. I'm just going to push it to the data inspector, and you'll see that when I do that, for a start, I get all of the data bunched up and sort of tucked away in a corner here. I can zoom in on it and get a little bit more detail, but you'll notice that there's no background map loading, and if I click on a feature, you'll see that the coordinate system is defined in SnakeGrid, and the coordinates are not what you'd expect to see for British National Grid. So what I'll do is I'll just disable this part of the workflow here, and I'm going to run it through to the output, and it'll go and pipe its way through the SnakeGrid projector. And in here I'm filtering the different geometry types out, so you can see that we've got different geometry types, points, lines, arcs that I've got defined in here. Any geometry that can't be handled by the SnakeGrid projector is just being filtered out. Let's just tuck that out of the way for a moment, and we're going to have a look inside the SnakeGrid projector. You can see that it's transforming to British National Grid from SnakeGrid, and we're using a specific parameter file that you get when you work on one of these projects. It gets provided with the tool. And what you can see in the inspector now is that if I just drag it in, you can see that we've got our project area, we've got our project data, overlain on some background mapping, and now if I click on a feature, you can see that we've got it recorded in Ordnance Survey projection now. So just one example of a tool that's available in FME to work on these specific transport projects. So let's have a look at some of the data that perhaps you and I might be more familiar with in our day-to-day usage. So many of us interact with rail data, whether we're travelling to work or visiting friends at the weekend, and train timetable and route information is being innovatively delivered to us if we want it. And that means that we can be innovative with FME as well. The data can be provided via an API. There's a couple of different standards that are quite prevalent out there, one more so than the other. REST is a pretty common API standard, SOAP is another. And often data feeds are also pretty common too, with feeds of XML files and XML's little brother JSON being really common ways of delivering data. CSV as well is also quite typical, and obviously FME can handle all of those very happily. One of the interesting things that we bump into a lot at the moment is that whilst FME supports a huge raft of standard data formats, one of the most common formats that we're asked to work with is actually an API. It's not really a format at all. It's an application programming interface, a way of getting at some data. So that's a way in which the data is being delivered to us, and it's managed by the REST standard in a lot of cases. And the HTTP caller is a great tool to allow you to get access to that data. So that's something to be aware of and have a go at looking at. And we'll see that in a few moments. But when you're trying to interpret the data that's being sent to you in XML and JSON format, these are the transformers that you should consider taking a look at. Often when you have data in JSON and XML, it's a very common document structure. So you read from top to bottom and you have something called tags in the document that it's helpful to be able to get into to extract certain bits of content. And you have nested relationships with parent and children tags. Now actually, if you're not familiar with that kind of data, it's quite a complicated structure initially. So these transformers exist to help you make that less complicated. The fragmenting tools allow you to split up the document. The formatter allows you to publish your data in those formats in a much more friendly structure. The extractor tools allow you to get certain portions out of the data, and the ones that are pretty common are to use are the flattening tools that take that document structure and flatten it out, or pivot it, if you like, into a structure that you can use when you're working with that data in a more tabular structure or loading it into a database. So let's go and have a look at some of the capabilities around some of these services. Well, National Rail Inquiries is an interesting one. That is data that's provided via a SOAP request. You can go on, make a SOAP request with a template. In this case, I can pass in the name of a railway station, and we can go and get back some of the service times. Let's just go and have a look though at the Knowledge Centre. SOAP requests are slightly harder to deal with than REST requests. So there's a really nice helpful document on the FME Knowledge Centre that takes you through some of the capabilities that are around building SOAP requests. So that's something to bear in mind. But let's go and have a look at a specific example that I've got defined. So we're looking at the National Rail Inquiries. I'm just going to tidy up after myself, close down the inspector and fire up FME Workbench again. And I'm going to pull in a pre-configured workspace that has the HTTP caller transformer nested in it. So let's just go and get that guy there. And here you can see that quite often when you work with transformers like this, you have a trigger feature. So the creator is just sending a trigger feature to the HTTP caller to post the request. And what we've got here in our main post request here is our request and a parameter that defines the railway station that we want the information for. And what we're going to go and do is send, we've got a parameter here that's been defined, and if we just go and edit the definition, you can see that we've got a bunch of codes. So it's the code that I'm using to pass in this case. So if I run this and say for Reading Station, give me some of the trains that are coming into Reading. So I've got the next 10 trains coming into Reading. There's no geometry here, it's just a tabular response in this case. And we can see that we've got a a Bournemouth train here that's heading off to Manchester Piccadilly, and we've got some train times in here. Turns out this one is delayed. There's a fault with signalling. There's another delay here because there's emergency services dealing with an incident. But we can also go and get information like the platform that these trains are coming in on, and the operator as well. So we can see a lot of the detail about the trains, and you can see this is live information because it's 11:25 at the moment, so we're looking at trains that are coming in at right now. So let's have a look at another scenario. This is a data feed this time. So this is from Northern Ireland. So TransLink are the operator for some of the bus and train networks in Northern Ireland. You can see that there's details here about the open data connection for real-time passenger information, if you're interested in having a look at that. And this is the kind of data that you'll get back. So in this case, you're getting back an XML feed of content. So if we go and have a look at an example of how we can interact with that kind of process, I'm just going to pull up another FME workspace, and we'll see a scenario. Here it is. Okay, so this is a slightly more involved workspace this time, just because what we're doing is we're building a URL. We're just using a string concatenator to add on a departure train station to build a URL. And this workspace also operates with the ability to specify the train station you want to leave from and the one you want to get to. So in this case, I'm going from Belfast to Bangor. What I can do is if I run it, it'll build the URL, it'll read the XML, and then what I'm doing is filtering out services that are not relevant to me. I'm dealing with working out what are all the stops along the route. That information is embedded within lists in the data, and I can also tidy up some of the attribution and then work out which was the train station that the individual wants to stop at, and produce a little report of the next trains that are going to that location. And what I want to do is present it to my user in a report. So I've got an HTML report generator that generates a little report, and I can go and preview that in a browser. And here we can see I'm basically building a little web page that tells us whether we need to run for a particular train. And here's the template. And this is something that we covered in one of our sessions at the FME World Tour earlier this year. So what we're going to do is just, we've run that process. Let's go and have a look at that data set. And you can see here that these are the next trains from Belfast to Bangor, and you can see that they haven't arrived yet. They're due in. The next one is due in at 11:40, so I am going to have to get a move on from where I'm based to get to Belfast. In this case, I don't think I'll manage it in 10 minutes, but and you can see that I've parsed out all of the stops that it's going to make along that route. The platform hasn't been changed. It's coming in on platform 4, so we're all good on that workflow. And what I could do to add a little bit of extra capability to this process is put that up to a public web service. So if I enable that part of the workflow and rerun it, and then everybody on the webinar, if you're interested, you can go to the URL just here, so bit.ly/FME train, and you too will be able to see that report, because what I've done is I've uploaded that to Amazon S3 and hosted and made that web report publicly accessible. So in theory, if I dive up to here, this is the hosted report that everybody will be able to see who's joined the session. Now, what you could do is you could get a FME server or FME cloud to run that report every 10 minutes for you during your commute period only, And then you can always be checking those train times. Obviously, there are a lot more use cases for how you could use this passenger transport information, but I just wanted to touch on one scenario there. Let's flip our attention to bus transport in this case. And the Department for Transport advocates the use of certain standards for exchanging information. In the case of bus schedules and related data, that's TransXchange. And it's used in things like journey planners and real-time tracking systems. And it's administered and prepared in relation to XML standards. So what we can do with FME is consume that data, because at the end of the day it's just an XML file. So if we just go and have a look at an example of processing that data, the key thing when you add an XML reader into FME is that you define the elements to match. In this case, these are the tags that I'm interested in, and I'm interested in stop points and route sections, which are effectively bus stops and the sections of the bus route between the bus stops. There are also other tags that you might be interested in extracting out of this data set. And what I'm going to do is flatten it out into a relational structure. So I'm going to bring in the stop points and route sections, build the start and end point of the section and turn that into a line, tidy up the attribution and sort the schema out. You can see that the incoming schema is quite involved. The outgoing schema matches that of the format I'm writing to, which is Esri shape. So I'm tidying up the content, making it fit for purpose for the format I'm writing to, and I'm doing the same for the bus stops. Although I'm going one step further, I'm concatenating the stop type values, because I can go to websites like Travelline and they have information around what the bus stop codes mean. So you can see that certain codes, for example, this is a BCT MKD is a marked pole. So it could be a shelter, it could be a pole. So you can get an indication of things like if you're looking at a management data set where you're managing the maintenance of certain assets, you might want to know, where all of your bus stops of certain types are, because there may be more cost involved in maintaining a shelter rather than a flagpole type bus stop. So in this case, if we just read our XML, we're going to write it out and produce some shape files as a result. And you can see that there's the two shape files, the stop points and the route sections that I've produced. But if we just go and have a look at the inspector, I'm just pushing the content out into here for a moment, and you can see that I've got a route section that goes through, and then if we just head to the nearest bus stop, you can see at this junction here, we've got a bus stop, and we can click on that bus stop, and it quite by chance happens to be the Spread Eagle Public House bus stop. I didn't plan that, honest, but you can see that there's an assortment of attribution that gives us a bit of detail about that particular stop location. So that's an interesting process to pull the XML content and construct it into something that we might want to analyze or store or move to another provider and work with in a GIS or a CAD system. And then there's lots of open data these days. It's really starting to serve us well for people who like to analyze and work with spatial and tabular data, not to forget about that kind of content. Organizations are either mandated or they're freely opening up their data. If you just go to data.gov.uk and just do a search for bus stops, you'll find that there's a whole raft of organizations that are serving up the content. Plymouth City Council is one of those organizations. You can see that they're supplying here a GeoJSON file that you can download. and that'll pull the data straight down into your browser, as you can see there, that you can work with or manipulate. But you can also go to their data place, and you can preview that content if you want to decide whether this data set is something you want to work with or can be of use to you. And you can see that there's a little browser that allows you to go and have a look at the individual bus stop information provided there. So that's a few things that are interesting, but how about processing that data with FME? Well, the one thing that's important for web data sets is that that data has probably got an update schedule, and we don't want to be manually going to download that data every 3 months, perhaps, if that's its update cycle. What we'd like to do is schedule an FME process to go and grab that data, and in this case, the same link here is the download link to go and get that GeoJSON file. So FME can actually manage the download for us, and we can run this on a schedule to load the data perhaps into our own Oracle database or into Postgres or into SQLite, or in this case I'm writing to Google Earth KML format. And that allows me to write the data, pull it down, download it straight from the web, style it, prepare it for wherever I want to use it. In this case, I get a little Plymouth bus KMZ file, which is a compressed KML file. I'm just going to download that and write that out to KML. And now I can go and have a look at the bus stops that I've got, that I've taken from the Open Data site, and I've defined them with their bus stop names. And you can see that now that we're in an environment that has a little bit of aerial imagery, we can zoom in and see that with the imagery, it's fairly obvious that here we have a stop on St Pancras Avenue, and conveniently placed on top of a couple of very obvious traffic regulation orders that define the extent of that bus stop. Now, the need for a base map I touched on at the start of the session, and I mean that's not exclusive to private transport. It just is something I want to incorporate into this this part of the session. Certainly, having a base map is very important for public transport analysis as well. But I touched on at the start of the session a couple of main providers. There's OpenStreetMap. Obviously, there are plenty of other map data providers. OpenStreetMap and the Ordnance Survey are just two that I'm referencing here. But that's because I want to highlight a couple of key points. First of all, FME has a dedicated OpenStreetMap reader, so I can demonstrate that by just going over to the inspector, and I've gone to the OpenStreetMap site. Let me just go back here. You can see there's an option on the website to export data for a particular area. So you can define the area you want. Here's the export button up in the top left hand corner, and once you've found the area you want at an appropriate zoom scale, you can manually download some content. And then once you've got that data, what you'll get is an OSM file. So if I just drag my little OpenStreetMap file onto the FME inspector canvas, you'll see it defines the reader, defines the data set, and this is just a very small snippet of data that I've got for the centre of Cambridge. There we go, so that's just rendering on screen, and I'm going to zoom in so you can see the detail. But this is freely accessible, freely available OpenStreetMap data. A lot of detail, a lot of feature classes or feature types or layers, whatever you want to call them, that include things like places, offices, different types of land use, and routes, public transport locations. You can see that there's also highway locations in here as well that you can add into the workflow. So lots of great content that's easily accessible. And obviously if you wanted to load your own database, your own file formats, then rather than using the inspector, you'd use FME Workbench and drag in the data set that you wanted to read. If you don't want to go to the trouble of downloading your own data set, then you can use a transformer that's available on the FME Hub. So if you go to hub.safe.com, you can see over here that you've got access to all sorts of free little utilities and tools. Many of them are free and easy to access, and we can go and find the OSM downloader transformer, and you can pull that little transformer down, and that will go and grab OpenStreetMap data for your area of interest directly within your workflow. So that's a specific transformer that can integrate as part of your routine. And then the other thing that I wanted to touch on here is that a lot of organisations and individuals within those organisations use FME to process their Ordnance Survey data for use within their day-to-day use. And I'm not going to talk about that in any detail, because we've talked about that adequately in plenty of our other webinar sessions that you can go and have a look at the recordings for on YouTube or on our on-demand section on our webpage, which we'll show you towards the end of the session. But the one thing I wanted to touch on that's interesting from an FME perspective is that the Ordnance Survey Master Map Highways Network is the new road routing and path network for Great Britain, and it supersedes the ITN, the Integrated Transport Network. And as I say, the only reason I'm mentioning it here is because it's one of the first Ordnance Survey products that the OS have actually provided FME workspaces for processing that data. So if you go and have a look at the Ordnance Survey's GitHub, you can see that there's a number of .fmw files. These are pre-configured FME workspaces that exist to work with the highways layer. So that's why we wanted to just highlight that at this point. And then there's some really interesting changes in personal transport and private transport, and you might talk about these organisations as being disruptors. Some people might refer to them as being innovators, but what they're doing is changing the way we think about getting from A to B. And Uber is a taxi firm that likes making headlines for one reason or another, but if you happen to want to interact with the Uber API, then FME has a pre-configured web connection. You can go to the hub and download the connection that has got all the authentication prepared for you, so that you don't have to go to the trouble of working out how to authenticate against that API. So that's available on the hub. And then there's, if you're more interested in two wheels, then we can look at innovations around working with bike sharing. When looking into the research for this session, one of the things that I discovered was a really interesting project called Bike Sharing Map. And this is a project that has been put together that gives us information about all of the locations globally where there is some sort of bike sharing system in place, which is a really interesting project to look into a bit more detail. And the GitHub site here is one that is really interesting from a scenario around these bike sharing capabilities, because this individual who's over in Germany, I believe, has put together a really solid site that goes through a lot of the documentation for some of the bike sharing organizations. So whether it's the organization called Nextbike or Ofo or Mobike or YoBike or whatever you want to call it, all of these different systems and how you can access the data that they are providing Obviously you can get involved and help and collaborate to work with some of this documentation. So there's clearly a to-do list for pony and donkey. So those clearly cycle sharing schemes that need a little bit of work to look at the documentation. But I mean, let's go and have a look at some of the scenarios here. So if we go and have a look at the next bike scenario, we can have a look at, for example, the locations that we can get a next bike hire in Cardiff City. So in South Wales, we've got access to lots of bike stand data, and you see there's one bike available at that particular stand. That is a bike. There's another stand with 4 bikes available at it. And what we can do is leverage the API that Nextbike have got to go and build an FME workspace and do something interesting with the data. If I fire up a little workspace that I've put together, what you can see in this process is the ability to connect to the API that Nextbike are providing. In this case, I'm not filtering by city. I'm just taking a fire hose of all of their bike information and setting the coordinate system, using the vertex creator to create a point on the map, and then I'm testing to see if the bike stand has got 5 or more or fewer bikes at it, and styling those stands up so that, you know, if I want to go to Cardiff and wander around, I can actually work out ahead of time which stand has got a few bikes at it, so that by the time I get there, hopefully there's going to be some availability. So if I zoom in on Cardiff, there we go, there's a background map. I'm just going to make the background a little less obvious, just so we can see our points. Basically anything that you can see in green is a stand that has got 5 or more, so we can see that there are actually 5 bikes available at that site, and there's the codes of the bikes. You might have made a note of the ID of a bike that perhaps you don't want to hire again, so you could check to see which ones are at the stand, so that you avoid certain bikes that might be due to go through a maintenance schedule, or you might want to avoid going to certain stands where there happens to only be one bike available. You know, if you've got a little bit of a walk to get to that location, you want to guarantee that there's going to be some availability when you get there. So there's a few interesting scenarios that are cropping up around these tools, and certainly vehicle tracking is going to be you know, something that we're going to see a lot, especially with developments in autonomous vehicles and electric vehicles, and in particular projects around smart motorways. The M42 in the West Midlands is a motorway that's had a smart motorway development, and certainly a section of the M6 is currently undergoing a major project to turn that into a smart motorway. What that's going to lead to is a lot of data that is going to be available to organisations working on those projects to manipulate and understand things like highway capacity and utilization. And that will allow us to understand and develop technology to better manage our capabilities around that type of logistical problem. And then there's individual vehicle tracking. Certainly certain vehicles may give you access to your own data that you have collated, including, you know, your vehicle's gear change, the amount of time that you have it switched on or using when you're being efficient at driving, and when your vehicle is autonomously driving. That kind of information might be available to you. Certainly fleet tracking systems like Masternaut are already out there, and they provide APIs to access, and for a couple of customers recently we've proved that FME is more than happy to interact with those vehicle tracking tools, depending on how that vehicle tracking solution serves its content. So let's go and have a look at a scenario. Here we've got let's go and pull up a sample example. So I'm going to bring in a simple workflow. Here you can see, if I just open up in Notepad, an example JSON file. So this is an example of a JSON feed out of a Tesla, and you can see that you've got information like the vehicle ID, the battery range, the current, whether the fast charger is plugged in. Hopefully if it's moving at a speed, which it is, then the fast charger isn't plugged in. Charge door is not open, key information like that. And that's just one tag. Then we've got another one and another one and another one. So we got each of these pings gives us a location of the vehicle at a certain point in time and what it's doing. So if we want to process that JSON data, we have a JSON reader in FME. We're just going to pull it in, set the coordinate system, create some points, and join the points together to give us a route. And here you can see all of the pings and also the route itself. So really similar to a couple of the examples that I showed you earlier on, but a subtly different context and scenario here. There, each of the GPS pings that the vehicle made, and the line is the route in between. So that information has been extracted from a JSON document, and now we can see the route that the vehicle traveled. In this case, it's going down Pryor Street, adjacent to Strathcona Park. So I'm coming towards the end of the webinar. So last couple of examples just to whet your appetite before we close. But as I say, hopefully this has been a useful session for you. Just to draw to the end here, one of the last examples is around avoiding road issues and dealing with private and in some respects public transport issues. So there's a few different providers out there that provide information around roadworks and road permitting and traffic incidents. Elgin is one organisation that has a system called, in this case, Roadworksorg, and you can see that there are a lot of locations pinging up onto the map here that give us indications of roadworks or incidents or permits where somebody's putting a skip on the road, or the water company is doing some work. In this case, Affinity Water are doing some work in that location. And here we've got Highways England doing some work on one of the trunk roads. And over here we've got an electrical company, UK Power Networks, putting a joint hole in the road on the offside, doing some trenching. This system is really interesting. They're a data aggregator. You can create a SOAP request to go and get information from that environment. So if we go to a little workspace that makes that SOAP request, you can see that you can post the request, get the content, and here we have a little workflow, in this case we're building some geometry of an area that we're interested in, and often this would come from a web mapping system where someone selects a location that they want to know what the traffic issues are in that area. We build the SOAP request in the XML templater and then post that request via the HTTP caller to the API, and then we get the content back. In this case, we're looking around the Brentford area in the UK, and we could write the data to Oracle Spatial, which is where this data ultimately would end up. In this case, I'm just pinging it to the inspector just so that we can see that. There we go. Okay, so now we can see all of the incidents. And these are all of the exact same points of interest that we were looking at on roadworks.org, but now we've got access to manipulate and analyze those. And in this case, you can see that I've picked on one there that is relating to some sort of pipe plastic pipe insert into a trench from London Borough of Ealing. So there's also providers like Highways England, which have incident information, and they serve up on a regular basis traffic information that are incidents that are going on the trunk road network. And you can see here that there's coordinates available in this document that tell us where the incident is and what type of incident there is in a particular location. And these incidents have event start and end dates. So what you can do is, because this event start, there is an end date here, that end date is in the future. What we can do is we can use FME to identify all the end dates that have passed for data sets that are being published and filter those out. So we're not looking at data that is irrelevant, because certain services like this will serve up content that not everybody needs to access. So you can use FME to filter out just what you need. So that's the conclusion. I really wanted to give you a large amount of scenarios within the public and private transport scenarios around data providers, data vendors, APIs, web services, different data formats, data standards, just to whet your appetite with the flexibility that FME has when it comes to processing and manipulating and managing data within the transport sector. And hopefully that allows you to go away with a little bit of excitement about some of the capabilities and things that you can deploy in your own organizations. What you'll hopefully be clear is that dealing with data translation with FME is really only part of the story. FME supports lots and lots of formats, but really what you're interested in is getting access to the data and the individual rows and documents. Where it's stored shouldn't be an issue. You don't want that to be part of the problem. You want to do something with the data and get it to where it needs to be. And that's where transformation is really important. So one of the benefits with FME is there is a huge global community of users using FME, and there are lots of organizations using FME. I've barely scraped the surface of some of the organizations that are involved with manipulating their data. So I'd like to thank you all very much and give you a few resources to go to. Go and have a look certainly at the Knowledge Centre, knowledge.safe.com. That's a good starting point, landing place for all of the information that we've covered. There are lots of articles. There's a really good community that myself and my colleagues are involved in contributing to. So do come and see us over there. But of course, if you buy FME from ourselves, and I know a number of you on the call today you have access to our maintenance and support contract. So you get technical support directly from us anyway. So come straight to us with any questions you have. Go and have a look at onespatial.com/FME to find out the details of anything we've got. And a lot of our historic webinars like this one sit on our YouTube channel, One Spatial Group. But if you go to our website, so if you go to onespatial.com, I will do that for you just now. So if you go to onespatial.com and go up to the events section, there is a section called On Demand Webinars. And some of the much more recent webinars you can go and subscribe to and dive in and have a look at. There's a number of them here that are related to all of the things that we do, but you can see that there's a few FME ones dotted through this collection of webinars. By all means, go and have a look. There's another vertical specific one there focusing on FME for water utilities, for example. Go and register and you can get access to those. But any questions that you haven't asked already in the chat window today that you'd like a reply to about this session, or anything else you'd like to discuss, drop us a note to fme@onespatial.com. And those of you that have asked questions in the chat, thank you very much. We'll be responding to those now. So we'll get back to you straight away. So if you want to hang on the line, otherwise, thank you very much. If you want to watch this session again, it will be up on our on-demand section of our website in the next few days, so you can catch any of those bits there at a later date. Okay. Thank you all very much for joining us. Do go and register for other webinars in the series. You can find those at onespatial.com/events, and we'll look forward to seeing you again. Thanks a lot.